Hey everyone, let's go ahead and see how you can make your Langchain agent with the explicit model instance. In a previous lesson, we had seen that how you can create a Langchain agent, but there we had used here implicit method to define our model. So what we did basically to define our model, we had provided our provider, that's the model provider, like the Ollama, OpenAI, Azure OpenAI, Anthropic, or whatever the model provider you select, and thereafter the model name here. All right. But now in this lesson, I'm going to show you how you can actually provide your model instance separately. So providing model instance separately gives you a lot of actually the option to set your model, basically a lot of options to set the parameters in your model. This is something which we are implementing, we are learning in this particular playlist, where we are learning how to implement the agents and how to work with the various the options and features of the Langchain version 1 agents, where you have LLM prompts and the tool user query comes here to the LLM decides to call the tool, and the tool returns the result, and so on. All these process goes on. As you already know, the code for this particular course is already provided. The code is here at my GitHub repository, Langchain V1 agent. You can get this particular code from here itself. You need to come to this repository. There is the code notebooks. Inside the code notebook, I have placed all the notebook here. All right. And if you want to see my previous videos on the Langchain version 1 agents, you need to come to here, the KCP Talkie, come to the playlist, and then you have Langchain V1 agent. We also have other playlist related to the MCP, related to the local LLM tutorials, or the Langchain version 1 projects, and so many other playlists here. And here is also the code available for the Langchain version 1 project, but we are looking for the Langchain version 1 agents here. Having said that, let's go ahead and get started with this. So the first of all, we are going to import here necessary Python packages. All right, so the first package we are going to import here, the ChatOllama. As you know that we are using here the Ollama itself. Where is the Ollama? Here it is. The Ollama is up and running. We are using the Ollama, and then we will be using here the Qwen 3 model to connect our notebook basically, or you can say that we will be using here the Qwen 3 model, which is running on the Ollama. All right, and the setting for this particular project is already described here in the project setups.md. This is the way how you install the related libraries. I have already provided those here, like the pip install, Langchain community. So this one says that the pre-version currently, that's the pre-version available for the Langchain version 1. By the time you watch this video, maybe you might be having the stable version, then you can directly install the Langchain. Otherwise, you can use the UV here. In the first lesson of this playlist, I have gone through with very detail, like how you can do all these project setup. So go ahead and watch the first video if you are struggling with the setup. Otherwise, continue with this particular video. And the other thing which I have been telling you multiple times, that this create agent has been now moved into the Langchain agents. Earlier it used to go in the LangGraph, but now we are importing it from the agents. Now we also import the tool here like we had done previously in our section 1, basically, in fact, in our video number 1, where we had imported the tool and then we had implemented their web search tool here. So the web search tool we have here, where we had used their DuckDuckGo web search tool to find out the real-time information from the internet. In this particular lesson, we are also going to use a tool here. As you see here, you make your agent with the tool itself. All right. So you have LLM, tool, and the prompt. All these three things comes together, then they makes an intelligent agent. Okay, that is how you make the agent. So we need to create here a tool. We can use the same tool which we have created, but just for the completeness and also for the variety, I'm going to make here the another tool. And also I'll be explaining how I'm making this particular tool. So I'm going to make here a tool which is going to calculate the expression. So the expression is going to be the various kind of the expression basically. You can provide there like some numbers multiplied by some other number, then the plus. So basically some mathematical expression you can provide, and then it is going to calculate. All right, it is going to evaluate that. All right, perfect. So basically what I'm trying to say here, that in that case, let's say you can provide some expression like, let's say maybe you have 3 multiplied by 4, and then you have a plus 2 minus 10, and then you might be having divide by 20, all these, right? So BODMAS expression, kind of all these things you can pass in your particular tool. Now it is going to use here AST library, all right? So, and literal evaluate library. This is the standard way to define your Python method, and this is the standard way to convert a Python method into a Langchain tool so that you can invoke your tool like we had done in our first lesson where we had used tools.wavesearch.invoke. Similarly, you can do for this one as well, tools.calculate.invoke, and then you can pass your expression. So this is very important. This is a decorator that is imported from the Langchain. If you see here that, all right, so this was imported from the Langchain. The tool decorator converts this standard Python method into the Langchain tool. Thereafter, we are going to import here AST library and the math library. So these two library will be used. I'm importing it here itself so that we can discuss this properly here instead of going at the top. Thereafter, we are going to parse here. Basically, what we are going to do here, we are going to find out that all the literals there, whatever the literals are there in the expression using the parsing method provided by the AST. All right. So AST.parse, as you see here, AST.parse, here you have this parse the source into an AST node equivalent to the compile source file name, etc. So what happened basically here, whatever expression you pass, it is going to parse and it is going to find out all these literals there. All right. And thereafter, we say that, okay, these are the things which we are going to allow in our expression for the parsing. All right, this is very important. If you use the evaluate method, in that case, you have to make sure that you allow only a specific set of the expression. Otherwise, some random code can be executed and that can create a security concern. All right. So here what you see, we have here expressions, normal expressions, constant, number, binary operation, unary operation, ternary, addition, subtraction, multiplication, division, modulus, power, subtraction, all right, addition, unsigned subtraction, unsigned additions, all these things we are going to do here. These are the only allowed node if you use here the AST module. There is another the expression evaluation method which we are going to also do here, like other allowed function in our calculate method, that is like ABS, round, minimum, maximum, summation, power, square root. So basically, once you have your expression, all right, once you have your expression, let's say you have your expression not like this, let's say you have your expression something like this, power of 2 or something like this. Now what it is going to do here, it is going to find out this power here. All right, maybe it is POW, probably, yeah, it is the POW. So it is going to find out that power, and then in that power it is going to pass these parameters. That is why a dictionary is made here. So in runtime it will identify these things there in your expression, and then it will replace those with the actual values here so that it can be executed. All right. Thereafter, we are going to check all the nodes here. So we write here like this, node item in ast.walk the node. So all the node, whatever the node is there in present in our expression. Thereafter, we say that here, all the node, whatever node we have found out here, that are those node in the allowed node or not. If it is in allowed node, only then we are going to execute this. If it is not, then we are going to say that, okay, this is unsupported operation. Okay, basically here we are saying that if not in allowed, then say that, okay, it is unsupported. Otherwise, evaluate this. So it is going to evaluate your expression, compile, and then the node here. So the node is here, this one. And in this node, whatever the nodes are there, only these functions are going to be evaluated. All right. And thereafter here it is going to say that it's going to use only built-in Python methods here to evaluate these nodes. So this is like a security safety here. All right. Thereafter, you just simply return your result here. All right. If everything has gone well, then you return the result. But as you see here, there is the try block. So in the except block, you are gonna say here except syntax error. Return error invalid mathematical expression. All right. That means if something happened in between here, then we say that invalid mathematical expression in case of the syntax error. If the zero division has occurred, if you have any expression where your number is getting divided by 0, then in that case you say here that zero division issue is found out there. Otherwise you write here except exception as E, then finally you raise the error. If those errors are not related to these, then you finally raise your error, something like this. All right. So our tool implementation is done here. That is the calculate tool. Now in this particular lesson, we are going to use that particular tool here. All right. So now what I do, I'm just going to execute this. Thereafter, this particular expression, what I have here, that expression I'm going to invoke here using the tools which I already have. Thereafter, I already have here the calculate. Then I'm going to invoke this. All right. So I invoke this expression and then I'm just going to execute this here. All right. As you see here that it is saying that this is the final result here. And if you see this tool, it is returning the same kind of things here. So result has been evaluated here and then your expression is there. With this, it is returning the final result that this is your original expression and here is the final result. If you do the calculation, you will find out that this is the perfect, all right? Because first division happens here, so it is 0.5. Thereafter 3 into 4, that becomes 12. 12 plus 2, that is the 14, minus 0.5, that becomes the 13.5. All right, so this is the exact calculation. Now, just for the the testing purpose, I'm just gonna see that if your LLM can do this calculation without the help of any tool. So I'm going to use the same model which I'll be using later on, the Qwen 3 8 billion parameter model. Let me see here if I have. Yeah, I have there. I'm going to say that here evaluate this expression. Let's go ahead and see if it is going to evaluate this expression and if it is going to give you the correct result. All right, so it is thinking here. After the thinking, it might produce the final result. So this is the beauty of the thinking model. In thinking model, they think a lot. And in this thinking process, they finally produces, generally, they produces the correct answer. Now we see here that they have, this particular model have produced here the correct answer. But let's say if we use here a non-thinking model, maybe like the Gemini 3 model, then see what happened here. All right, so the same thing I'm going to use here, but with the new chat. All right, then I see like this, and let's go ahead and see if it is able to evaluate this. As we make it complex later on, it might become a difficult, but seems like this was also able to calculate this. But as you already know that many times you might have seen with the ChatGPT and other models, where you pass mathematical operations to compare some numbers, then they used to produce the wrong answer. To solve those things, you can use tools, something like this. Having said that, let's go ahead and proceed with our agent creation. So as I have already discussing with you that we are going to discuss here that how you can create your model instance separately and then you can pass it to the agent. And model creation separately provides you a lot of flexibility where you can pass a lot of parameters, you can customize your model. So we are going to use here the ChatOllama. Earlier we used to use the Ollama directly with our model, something like this, and the model name. But this time we are going to create our model instance separately. So this time we are seeing here the model equal to the Qwen 3. Earlier I had used the 30 billion parameter model, but now I'm going to use the default one, that is the 8 billion parameter. So I defined my model, but if you put your cursor here, then you see all these parameters here. So basically, you can select any of these parameters. You can set any of these parameters. Some of the important parameter which you have to set here, like the model and the base URL, basically. So these are the important parameter which you have to set, and the rest of the things you can keep as a default. Otherwise, if you want, you can set others as well. Thereafter, you have a base URL. This is where my Ollama is currently running. And thereafter, I'm going to set here the temperature equal to the 0. If you set a low temperature, then that is going to give you the consistent result, basically. All right. So we have established our model instance here separately. Now our model is ready. Now we can pass our model and the tools to our agent. I'm just gonna create my agent here. So the agent equal to the create agent model and then the tool. Do remember, we are not passing the prompts as of now. Currently the system prompt is none. Don't worry about that. LLM does not actually, make system prompt must. So basically, it is not always necessary to give the system prompt. But as you know, I have been discussing this a lot here. Like we have to also give the prompt and the tools and then the LLM for our agent. But you can skip the prompt as well. You can go with the no system prompt at all. Your agent will work. All right. It might not work as intended, but it will work. So the question is here, like why we are not giving our prompt here right now, because you see we already have here a separate lesson for the prompt discussion. So as we move forward in this particular lesson, then I'll be showing you various ways to set the prompt. All right, perfect. Now our agent is created here. Let's go ahead and execute this. As you see, your agent is created, and if you visualize your agent, just type your agent, you can visualize this. So your query comes here, it goes to the agent connects with the tool, and then tool returns the output, then it goes back to the agent, and this whole process goes on until your LLM decides that, or your agent decides that I have my answer for a particular query, then it can finally end it. This is the overall process. Later on, I'll show you how this end is actually executed. All right. Then you have the testing the agent. Let's go ahead and test our agent. So it is pretty much simple process. So what I do here, first of all, I'm going to invoke my agent with the message, what is 15 into 27 plus 100? All right, this is one of the simplest method. Basically, this is one of the simplest question I'm going to ask. And then finally, I'm going to print this. All right, so I have my response here in the result. Let's go ahead and execute this. And the one thing you will also notice here that we are printing the last message here. So why last message? I'll show you. Let me just print here final result basically, and then you will understand. So your result have here so many messages. So the first message goes as the human message, and then the AI message. This is where your LLM decides to call a tool. If you see there, as you go there, maybe not there. As you see, response metadata, maybe before that probably, or after that, I have to find out here. Let me find out. Yeah, here it is. All right, so in the tool call, it has decided here to call a tool, and the tool name is calculate here. And it is passing this particular expression. So this expression is coming from the message itself. It did not pass a whole query, but it has extracted the expression and only relevant data is passed there. Thereafter, the tool was executed, and then this goes into the tool, and tool returns this final answer here. All right. And then that final answer again goes to the LLM, and then AI thinks, and then finally AI produces the final result here. All right. That's the final answer. So the result of calculation is 505. This is how overall agent calculation is being done. So if you want to print the last message, this is how you can print the last message. There are other ways to print the last message as well, like using the pretty print. All right. So you can write here something like this. Probably, I guess I'm just trying out if it is available or not. This is your last message. And maybe you can write here pretty print or p print. I need to see here that if it is allowed here. Yes, there is the pretty print. All right. So you can use this pretty print. In that, it is going to print very much a formatted string here. All right. Perfect. So this is how you can define your model instance separately. And there are other parameters which is available, which you can define here to experiment with various parameter setting. So the one thing you will notice here that after thinking, there is the final result. So in the final result, it has just produced a single sentence. And that is why this particular thing is happening, because we have set here the temperature 0, if you remember. All right, while creating our model instance, we have set a temperature 0. So the low temperature means your model is more consistent. Let's go ahead and see if we set other settings. So what are the other settings available? Later on, I'll show you. Basically, here I'm going to show you what are the other settings available here. So again, we have this particular question, explain what 2 plus 2. Basically, here we are trying to get the reasoning, and then we will be setting various parameter, and then I'll be explaining you here. So we start with our ChatOllama first of all, and we set our model. Thereafter, we set the temperature here, temperature 0 again, so that we can reduce the randomness. Later on, I'll show you, as you set the larger the temperature, then you will see you will get more randomness in your final answer. We are going to set here the top P. So the top P is going to say here that whatever probable tokens are predicted, you need to select in top 1 percentile only. All right. So how the LLM predicts, basically, if I need to tell you here, it actually creates there a probability here, right? For the token. So it is going to say here that, okay, this is the top 1% probability for the tokens. So you need to select only those tokens which falls into this top 1% probability. All right. Or you can say that, in fact, that is not there, the top 1%. Basically, you can say that here it is. All right. So this is going to be the top 1% probability. So it is going to select from the top 1% probability. So if you make this number lesser and lesser, your model is going to be the more consistent. Why? Because for sampling, it is having less number of the tokens. So if it has a less number of tokens, then final result will be obviously more consistent. Then in this top 1%, it is going to use the sampling method to get the final answer. The repeat penalty, we say here that 1.1. Basically, we say that do not repeat the token. All right. And how much look forward window we are going to allow for this one? We are going to say here, there is some default, default window, like some tokens, 32, 64, 128 tokens there, where you need to provide there, or you can just leave that as it is, like this one, repeat last n. So it is n. So basically, whatever the numbers total are generated, based on that, it is going to select that. And we are going to say that, okay, let's go ahead and generate max to max 500 tokens, and do not generate more than 500 tokens. That's all. And we are going to say here that, okay, total 4096 is going to be the context window for your overall messages. As you had seen previously in our messages, you have a list of messages like this. All right. So if you see the total number of tokens goes beyond 4096, then your LM will start losing the context which has came here. All right. It will be having the context only for the recent messages. And then C42 we are going to say, so that we can reproduce the result. Then we finally create our agent, and then we are going to invoke, and then finally we are going to print our result here. Let's go ahead and print it and then see how it is going to produce the result. Thereafter, the same kind of the answer, same kind of the question we are going to ask with a different setting, and then I'll show you. As you see, thinking was done here, a little bit thinking, and thereafter the reasoning here. 2 plus 2 equals 4 because of all these things here. All right. Now, if we do the same setting, if we ask the same question with the different setting, then let's see what happened here. So everything I'm going to set as it is, only the temperature is going to change here. Temperature is going to be the 2, and the top K I'm going to set here the 200. The another thing you will notice here, we had a top P. So it is the percentile of total predicted token. So here we say that 1%. But now we are seeing here just 200 tokens. So it is going to select from top 200 tokens only. So this top K says that just top 200 tokens. Repeat penalty is again the same here. repeat last, we are going to select the 64 here. So in the 64 window, it is going to look and it is going to say that we will not repeat here. Number of predict is 100 here. This is very important. So basically, as soon as it predicts the 100 token, it is going to stop the generation. And thereafter, the number of context I have increased here a little bit. It is out of the context completely. Don't worry about that. I have been just experimenting with various settings. Just wanted to show you that what are all settings available here. Keep alive equal to the 5 minutes. That means what happened here. Once this loads your model into the Ollama, then this one is going to say that load your model. Basically, keep your model setting up for 5 minutes there. Basically, if you check your task manager here, in the task manager, you will see your settings basically for the GPU load. So the GPU is already loaded. Let me see here. GPU is already loaded here. All right. So very small model GPU is loaded and it will keep for some time. With this, we say here that keep it loaded for at least 5 minutes. And let's say if you don't have a GPU, then you can say that I want multi-core processing on the CPU. That's you can say number of thread equal to the 4. All right. Having said that, let's go ahead and see the final result. We are going to execute and then I'll explain again what is happening here. So all these things are very important. As you see here, it has started thinking token. And if you notice, it has done a lot of thinking. Previously, there was only one line of the thinking, but now multiple line of the thinking. But the final result is not produced. Here, abruptly, our model has stopped. Why? Because we have provided the number of token prediction to the only 100 here. And the number of context is quite large, but the prediction token is 100 only. Let's go ahead and check this to the agents here, basically at our Langsmith. If you have watched first video, there I have shown how you can do all these setups here. So I come here, this was my question. In this particular question, you have all these setups here. Let me just see. Not this one, probably, yeah, here. So as you see, this was your LangGraph. Just click again here. And the total number of tokens, run count. Let me just see that if we have total tokens for that particular model. Seems like we don't have anyway. You can just click here. Then you can see here. So your agent started execution and then the should continue was called here. In the should continue, it has decided there to, seems like it could not call the tool basically. All right. So it has ended because the total number of generated token has reached their limit. Seems like this one says that the total number of generated token, that is the output token here. All right, the 100. So this is where your model stops. Now what you can do if you want the final answer, so you can increase the output token. So max 1000 token it can generate, but your model can stop before the 1000 token. Let's go ahead and rerun it again and then check what happened here. Now it is able to think here properly and then it is able to produce the result here properly. The one thing you will notice here that this time this reasoning is a little bit better than what we had seen here. All right. And if you want to increase your reasoning more than this, what we are currently seeing, you can increase this top K. Let's say if you increase the top K to 200, now you will see a lot of hallucination kind of things you must be seeing here. As you see here, now it has gone like this one. All right. You can see here a lot of more, the thinking has gone. But as you increase this temperature, let's say more randomness will be introduced here, as you see here. All right, temperature 5 is not going to work. But if we work with the temperature 3 here, so we see the output is going to be like this. And some special character has now started coming here. As we increase the temperature to 4, maybe now it should be coming some random number, I guess, probably. I'm not sure what it is going to give us. Yes, here. All right, now you see your model performance has decreased completely. Why? Because as you set more temperature, basically higher the temperature, your model is going to perform worse there. All right, so basically it is going to be more explorative. So basically it is going to explore more number of tokens. It is going to be more innovative. And in case of it is going to be more innovative, then it is highly probable that it is going to produce a lot of the random tokens there. All right. Now you see here, there is a lot of the thinking. But let's say if you want to stop the thinking, then how you can stop the thinking. So as you come here and then for the thinking, you have there some parameter that is known as a reasoning parameter basically. So you need to set your comma here basically, and thereafter you have their reasoning here. All right, and you set here the reasoning is false. So basically it is going to set that thinking mode as a false here. So now if you execute, it is going to produce the final answer directly here. All right. And the one thing you will notice here, our question here. So this was our question. Let's go ahead and print our question here before the answer, so that will help us to understand. This is our question. So the question was explain 2 plus 2, all right, equal. And if you remember in the previous execution, we had got there the dollar. Why those things are happening? Because of these temperature, high temperature, and because of high top K. And if we execute it again, then we should be seeing here various kind of results. All right. Now you see here all these things. As we set larger the temperature, the more randomness we can get. But if we set this reasoning is true, then it is going to produce the thinking tone as well. So basically it is going to think as well. All right. Seems like thinking is not enabled. Let me just check here that in this we should be having our reasoning here. So it is a Boolean, as we had passed there, verbose and all these things are there. Let me just see here. Reasoning is there, correct. Okay, it should be producing the reasoning, but seems like somehow it is not producing the reasoning. Anyway, that could be the fault of the Ollama API itself, probably. That's what I'm thinking. Now, it has not produced any result. That is really odd. And having said that, now I hope that you have understood that how you can create your agent with the... Yeah, this is really not good, basically. All right, now having said that, now I hope that you know that how you can create a separate model instance and then how you can work with your agent. All right, this is all about in this lesson. Bye-bye. Take care.